Welcome to my sleep science channel. Like, subscribe, and tell me where you're watching from. Tonight, we begin a gentle journey into one of the strangest ideas imaginable. What would happen if the universe itself started turning upside down? It sounds like something from a dream, or perhaps a scene from a science fiction story. Yet, the question invites us to think carefully about the nature of space, gravity, and the meaning of direction itself. As we slowly explore this unusual possibility, we will move through familiar places and enormous cosmic distances, always beginning with the things we know best. When most people hear the words upside down, they immediately imagine standing on their heads, or perhaps seeing a room flipped over. Here on Earth, up and down seem perfectly obvious. The floor is below us, the sky is above us, and gravity keeps our feet firmly planted. Every day, we move through life with a strong sense of orientation. Buildings rise upward, rain falls downward, and trees stretch their branches toward the sky. These experiences feel so natural that it is easy to assume that the same directions exist everywhere in the universe. Yet the universe itself is a very different place. Astronauts floating inside spacecraft quickly discover that up and down become almost meaningless. A person can eat while upside down, sleep on a wall, or rotate slowly through the air without feeling strange after some time. There is no cosmic ceiling and no universal floor. Direction is something that depends largely on where you are and what forces are acting upon you. Imagine two astronauts approaching each other in deep space. One of them might consider themselves perfectly upright, while the other appears completely upside down. From the second astronaut's perspective, however, the situation is reversed. Neither person is actually wrong. In the vast emptiness between stars, orientation becomes a matter of perspective rather than an absolute truth. This simple idea reveals something remarkable. The universe does not come with labels that say above or below. Galaxies are not hanging from a giant ceiling, and stars are not resting on some enormous cosmic ground. Everything exists in every direction at once. When astronomers create maps of the sky, they often place certain regions at the top, simply because humans prefer organizing information that way. Another civilization somewhere among the stars might arrange those same maps completely differently. Because of this, asking what would happen if the universe turned upside down leads to an interesting challenge. What exactly would be turning? Would space itself rotate? Would galaxies flip over? Would gravity suddenly reverse? Or would observers merely experience the illusion that everything had changed orientation? These possibilities are very different from one another, and each creates a unique picture of cosmic transformation. To understand the idea more clearly, it helps to begin with familiar examples. Consider a globe of Earth resting on a table. People living in Australia are often jokingly called upside down by people living in Europe or North America. Yet Australians do not feel upside down at all. Gravity pulls everyone toward the center of the planet, giving each person their own sense of downward. There is no privileged direction that applies to everyone equally. The same principle extends to the moon, the sun, and the countless stars scattered across the galaxy. Every world has its own local orientation. Mountains point away from planetary centers. Oceans settle according to gravity. Atmospheres wrap around planets like blankets. Each location creates its own understanding of above and below. As night falls and people gaze upward into the sky, it may feel as though the stars are suspended overhead. Ancient civilizations often imagined enormous domes surrounding the Earth, filled with shining lights. These beautiful ideas helped people understand the heavens before modern astronomy revealed a much larger and stranger reality. In truth, there is no universal roof stretching over humanity. The stars surround us in every direction, extending outward across distances so immense that ordinary numbers struggle to describe them. The notion of an upside-down universe therefore becomes less about flipping objects and more about understanding the hidden assumptions humans carry with them. Our brains evolved on a planet with constant gravity, steady horizons, and familiar landscapes. Those experiences shaped the way we think. Yet, the cosmos itself is under no obligation to follow the habits of human intuition. Perhaps that is one reason the night sky inspires such wonder. It quietly reminds us that reality is often stranger than our everyday experiences suggest. The stars do not care which direction we call upward. Galaxies spin silently without reference to human ideas. Vast clouds of gas drift through space with no preferred orientation. The universe simply exists, enormous and indifferent to the labels we assign to it. And so our story begins with a simple realization. Before imagining a universe turning upside down, we first discover that the cosmos may never have possessed a true up or down in the first place. The directions that seem so obvious on Earth gradually dissolve into perspective, and what remains is a deeper appreciation for the strange and beautiful structure of reality itself. Yet once we leave the familiar environment of Earth, these ideas begin to fade. The universe does not contain giant arrows showing which way is upward. There are no signs placed among the stars telling galaxies how they should orient themselves. Instead, direction depends almost entirely on the local surroundings and the forces acting upon them. The reason humans developed such a strong sense of orientation is simple. We evolved on the surface of a planet. Earth constantly pulls us toward its center. That pull creates the feeling of down. The opposite direction naturally becomes up. Plants grow upward because sunlight comes from above and gravity acts below. Rivers flow downhill because gravity determines the path water follows. Entire civilizations have built their architecture, language, and understanding of the world around this invisible force. But imagine floating thousands of kilometers above Earth aboard a spacecraft. There, gravity still exists, yet everything inside appears weightless. Hammer released from your hand remains suspended in front of you. Water forms drifting spheres. Sleeping bags can be attached to walls, ceilings, or floors because none of those surfaces have any special meaning. Astronauts often speak about becoming disoriented during their first days in orbit. Some find themselves accidentally working upside down relative to their crewmates without even noticing. Photographs from space reveal something even more interesting. Earth itself can appear in any orientation. Sometimes the North Pole is shown at the top. Other times, the South Pole appears above. There is nothing physically wrong with either image. Humans simply prefer maps with North at the top because of centuries of tradition. Another civilization elsewhere in the cosmos might place South at the top or arrange maps sideways. The universe would remain completely unaffected. This idea becomes even more fascinating when we consider the stars. When astronomers observe distant galaxies, they find them oriented in every imaginable direction. Some appear tilted, others spin at strange angles. Spiral arms twist gracefully through space without any universal alignment. If you could somehow travel outside our galaxy and look back at the Milky Way, you might decide to rotate your view completely upside down. The galaxy itself would not notice. Its stars would continue orbiting exactly as before. Even constellations, which seem fixed and familiar from Earth, are products of perspective. The shapes people recognize in the night sky exist only because we view certain stars from a particular location, from another planet, orbiting another star. Those same stars would appear scattered differently. Famous patterns that humans have admired for thousands of years would disappear, and new arrangements would emerge. Ancient cultures often imagined the heavens as structured layers above the earth. Some believe stars were attached to crystal spheres. Others pictured enormous domes stretching over the world. These ideas made sense because they matched everyday experience. People naturally associated heaven with above and the underworld with below. The sky represented mystery and power, while the ground symbolized stability and familiarity. Modern astronomy revealed something much stranger. There is no top layer of the cosmos. Space extends outward in every direction. Galaxies are scattered throughout immense distances like islands across a dark ocean. No matter where observers travel, they tend to see themselves as being at the center of their surroundings. Every location feels equally natural because the universe does not favor one direction over another. Imagine standing on Earth while someone stands on a planet orbiting a star thousands of light years away. Both observers point toward their respective skies and call that direction up. Yet their definitions of up may differ enormously. In fact, those directions could point almost opposite to one another. Neither observer would be wrong. Each is simply responding to the local effects of gravity. This strange reality means that the concept of an upside-down universe is not as straightforward as flipping a picture on a screen. If everything in existence rotated together, no one inside the universe might notice anything at all. Stars, planets, and galaxies would maintain their relationships with one another. The transformation would resemble rotating a globe while everyone standing on it rotates along with it. Without an external frame of reference, the change might be impossible to detect. Nature itself offers countless examples of orientation being relative rather than absolute. Fish swimming in the ocean do not care whether divers above them consider them upside down. Bats sleep hanging from cave ceilings without feeling unusual. Spiders walk across surfaces in ways that appear strange to humans. Perspective shapes interpretation. Perhaps the same is true on a cosmic scale. The universe may possess no preferred direction, because direction itself is an idea created by observers living inside it. Up and down are incredibly useful concepts for daily life, but they are not fundamental ingredients of reality. They emerge from local conditions, from gravity, and from the ways intelligent creatures experience their environments. As the stars shine quietly across the darkness, they remind us that the cosmos operates on scales far beyond ordinary intuition. The more deeply humanity studies space, the more it discovers that many assumptions carried from everyday life do not apply universally. What seems obvious on Earth often becomes wonderfully strange among the galaxies. And so, before imagining great cosmic inversions and extraordinary transformations, we slowly come to understand that the universe itself may never have possessed a true up or down at all. What appears solid and certain from our small world becomes fluid and relative across the immense stage of the cosmos, where direction is less a law of nature and more a matter of perspective. Life on Earth has trained human beings to believe that up and down are universal truths. From the moment people learn to stand as children, they begin developing a powerful sense of orientation. The ground beneath their feet feels permanent and reliable. The sky stretches above them, clouds drift overhead, and objects dropped from a hand always fall downward. These simple experiences become so deeply woven into everyday life that most people rarely stop to wonder whether up and down actually exist beyond the environment of our planet. The answer begins with gravity. Earth is not pulling everything downward toward some cosmic floor. Instead, it pulls everything inward toward its center. This distinction is important because it means that every person on Earth experiences a different direction of down. Someone standing in Istanbul has a downward direction that differs from the downward direction experienced by a person in Argentina or New Zealand. Both individuals feel perfectly upright because gravity defines their local orientation. This becomes easier to imagine by thinking of Earth as a giant sphere floating through space. People are spread across its surface in every direction. From one perspective, some individuals appear upside down compared to others, yet nobody notices anything unusual because everyone is being pulled toward the center of the planet. There is no absolute top or bottom to Earth itself. Human beings simply experience local versions of these directions. For thousands of years, people assumed that Earth occupied a special position in the universe. Ancient civilizations looked upward and saw the stars slowly crossing the night sky. The heavens seemed fixed and orderly, while the Earth beneath appeared motionless and stable. It was natural to imagine that the world sat at the center of creation and that everything else revolved around it. Such ideas influenced myths, religions, and early scientific thinking for centuries. As knowledge expanded, people gradually discovered that Earth is moving constantly. It rotates once every day, while traveling around the sun at tremendous speed. The sun itself moves through the Milky Way galaxy. Meanwhile, the galaxy is traveling through space along with countless neighboring galaxies. Even while sitting quietly in a chair, every person on Earth is participating in an extraordinary journey through the cosmos. What makes this remarkable is that none of these motions can be felt directly. Human beings experience them as normal because everything around them moves together. Oceans, mountains, buildings, and entire continents accompany Earth on its path. There is no sensation of racing through space because no external reference point announces the movement. Reality feels calm and stationary, despite the incredible speeds involved. Gravity itself is one of the most familiar forces in daily life. It determines the shape of rivers, the growth of trees, and the way rain falls from clouds. Birds fly against it. Mountains rise above landscapes because of it, and oceans remain wrapped around the planet because of its influence. Without gravity, the atmosphere would drift away into space, and life, as we know it, it would not exist. Yet gravity is surprisingly weak compared to some of the other forces found in nature. A small magnet can lift a paper clip against the pull of the entire Earth. Nevertheless, gravity possesses one special quality. It acts across enormous distances. It governs the motions of moons around planets, planets around stars, and galaxies across vast regions of space. It quietly shapes the architecture of the universe itself. Human language reflects the importance of orientation. People speak about climbing upward toward success and falling downward into failure. Happiness is often associated with rising spirits, while sadness is described as feeling low. Even architecture mirrors these ideas. Towers stretch upward toward the sky, and underground places often evoke mystery or unease. These associations have developed because generations of people have lived under the same gravitational conditions. Different environments, however, reveal how flexible orientation can become. Astronauts aboard orbiting space stations quickly adapt to a world where ceilings and floors lose their meaning. A person may begin working while attached to what another crew member considers the ceiling. Tools can be stored in any direction. Sleeping bags may be secured against walls. Over time, the brain accepts these strange conditions and creates new definitions of normal. Marine animals offer another example. Fish swim freely through three-dimensional environments where movement upward or downward carries little emotional significance. Dolphins and whales navigate oceans with remarkable ease because their surroundings allow complete freedom of orientation. To them, the distinction between above and below is far less important than it is to creatures living on land. Even the stars themselves do not respect human ideas about direction. Telescopes reveal galaxies tilted at every imaginable angle. Some appear edge-on, while others face observers directly. Spiral arms sweep gracefully through space without any concern for which way humans consider upward. From another location in the universe, the Milky Way itself might appear completely upside down. These observations slowly lead to a fascinating realization. Up and down are not properties built into the universe. They emerge from local circumstances. Gravity creates them. Perspective defines them. Human experience reinforces them. But beyond the familiar surface of Earth, these concepts become less rigid and more fluid. Understanding this prepares the mind for a far stranger possibility. If the universe somehow began turning upside down, what would that even mean for creatures whose entire understanding of orientation originates from the gentle pull of a single planet? The answer becomes increasingly mysterious the farther one looks beyond Earth and into the immense depths of the cosmos. where familiar assumptions gradually dissolve and reality becomes far more extraordinary than everyday experience might suggest. Among all the strange possibilities surrounding an upside-down universe, perhaps the most fascinating question is not whether planets or stars could flip over, but whether space itself could slowly begin to rotate. Such an idea sounds almost impossible because people normally think of space as an empty stage upon which everything else exists. Mountains, planets, galaxies, and even light travel through space, but space itself often feels invisible and motionless. Yet modern understanding has shown that space is far from a passive background. It stretches, bends, and responds to the presence of matter and energy. This raises an intriguing thought. If space can expand and curve, could it somehow experience a gigantic change in orientation? To appreciate how unusual this possibility would be, it helps to imagine a familiar example. Picture a calm lake during sunset. Boats float peacefully upon its surface. From the perspective of those inside the boats, everything appears stable and ordinary. But if the entire lake itself slowly began to rotate, every boat would be carried along with it. People standing aboard might not immediately notice the movement because they, the boats, and the water would all be participating in the same transformation. Something similar could occur on a much grander scale. If the fabric of space itself began undergoing a slow rotation, galaxies, stars, planets, and even human beings would likely move together with it, since everything around observers would share the same motion. Detecting the change might prove surprisingly difficult. There would be no external signposts beyond the universe against which the motion could easily be measured. This idea touches upon one of the strangest aspects of reality. Human beings naturally assume that there must be some larger frame of reference, some ultimate backdrop against which motion can be judged. Yet, the universe does not appear to provide such a structure. There is no giant room surrounding the cosmos. There is no cosmic ceiling from which galaxies hang. As far as observations reveal, the universe contains everything known to exist. If that entire structure changed orientation together, there might be nothing outside it capable of revealing the transformation. On Earth, movement is easy to recognize because people compare themselves to stationary surroundings. A train passenger notices motion by observing trees and buildings outside the window. A sailor can detect the movement of a ship by watching the coastline. But if everything visible moved together at precisely the same rate, determining whether motion existed at all would become extraordinarily challenging. This thought experiment becomes even more interesting when considering timescales. Imagine that space began rotating so slowly that a complete inversion required billions of years. No individual human would ever notice the process. Entire civilizations might rise and disappear without recognizing that anything unusual was happening. Generations would inherit a cosmos that seemed perfectly normal because the transformation would occur on scales vastly exceeding human lifetimes. Nature already provides examples of changes so gradual that they escape immediate detection. Continents drift across Earth's surface at speeds comparable to the growth of fingernails. Mountains slowly erode over millions of years. Stars evolve across immense spans of time. From the perspective of a single day, these changes appear non-existent. Yet over geological and cosmic ages, they reshape worlds. Suppose astronomers somehow possessed instruments capable of detecting such a rotation. What signs might they observe? The positions of galaxies could slowly shift relative to one another. Patterns in the cosmic background radiation might reveal subtle changes. The motions of galaxy clusters could display tiny irregularities that accumulated over unimaginable periods. Such clues would be incredibly delicate and difficult to interpret, requiring generations of observers patiently gathering information. Ancient people once believed the heavens revolved around Earth because the stars appeared to circle overhead each night. Only through careful observations did humanity discover that Earth itself rotates. What seemed obvious turned out to be an illusion created by perspective. Perhaps future civilizations, possessing technologies beyond current imagination, might uncover equally surprising truths about the deeper structure of space. The concept of rotating space also reveals how strongly human intuition depends upon ordinary experience. Everyday objects move within space, not with space. Cars drive across roads. Birds fly through the atmosphere. Ships travel across oceans. These examples train the mind to separate objects from their environments. But the universe itself may not follow such familiar patterns. Space and matter are deeply connected, influencing one another in ways that often defy common sense. Interestingly, many of the largest structures observed throughout the cosmos already possess motion. Galaxies rotate majestically. Stars spin upon their axes. Planets turn endlessly while orbiting their suns. Black holes whirl with astonishing speed. Rotation appears throughout nature, from tiny particles to enormous collections of galaxies. Motion and change are woven into the fabric of reality. If the universe itself gradually began participating in some unimaginably vast rotational process, life inside it might continue peacefully for extraordinary lengths of time. Oceans would still rise and fall. Seasons would continue their familiar cycles. Civilizations would build cities, write books, and gaze upward at the stars without suspecting that the stage upon which all existence unfolds was slowly undergoing a transformation beyond ordinary comprehension. Perhaps the greatest lesson hidden within this possibility is not about rotation itself, but about perspective. Human beings experience reality from a very small corner of an immense cosmos. The assumptions that feel natural and unquestionable on Earth may represent only a tiny fraction of a much larger story. As understanding deepens, familiar concepts often become stranger, and mysteries that once seemed impossible begin to invite quiet curiosity. In the endless darkness between galaxies, where distances are measured in millions of light years and time stretches across unimaginable ages, even the idea of space itself turning upside down becomes a gentle reminder that the universe is far more mysterious, subtle, and beautiful than everyday experience would ever lead us to believe. If the universe somehow began turning upside down, and if this transformation happened slowly enough to preserve the stability of stars, planets, and galaxies, the earliest signs would almost certainly be subtle. There would be no sudden moment when people looked out their windows and saw cities hanging from the sky. There would be no dramatic flipping of mountains or oceans. Nature rarely operates with such theatrical simplicity. Instead, the first hints would likely emerge through careful observation, patient measurements, and small mysteries that gradually accumulated over generations. Human beings are remarkably sensitive to patterns. Throughout history, civilizations have tracked the movements of the sun, the moon, and the stars with extraordinary precision. Ancient cultures used the sky as a calendar, a clock, and a map. Farmers planted crops according to the seasons. Sailors navigated oceans using familiar constellations. Entire monuments were constructed with astonishing alignments to celestial events. Even before modern science, humanity developed a deep awareness of the heavens above. Because of this long tradition, astronomers would probably be among the first people to suspect that something unusual was occurring. Their instruments continuously monitor the positions and motions of countless objects across the sky. Tiny irregularities that would escape ordinary observation might slowly begin to reveal themselves through decades and centuries of accumulated data. At first, the changes might seem insignificant. A distant galaxy could appear slightly displaced from where mathematical predictions expected it to be. The rotation of certain star clusters might exhibit unexpected variations. Patterns in the cosmic background radiation, that faint glow left over from the earliest stages of the universe, could show delicate asymmetries that scientists struggled to explain. None of these observations alone would immediately suggest that the universe was somehow turning upside down. More likely, researchers would propose numerous competing explanations and spend generations debating their meaning. History shows that this process is common. Many revolutionary discoveries began as tiny inconsistencies. The planet Neptune was discovered because astronomers noticed slight disturbances in the orbit of Uranus. The existence of dark matter emerged from observations that galaxies were rotating in ways that visible matter alone could not explain. Even the expansion of the universe itself was revealed through subtle measurements of distant galaxies. Reality often whispers before it speaks loudly. For ordinary people living their daily lives, the world might seem unchanged for a very long time. Children would still attend school. Birds would migrate with the seasons. Rain would fall. Forests would grow. Oceans would continue their rhythms. Human civilizations might experience wars, discoveries, and cultural transformations without realizing that an even larger process was unfolding in the background of existence itself. Over centuries, however, patterns in the night sky could begin changing in ways unlike anything previously recorded. Constellations already shift slowly because stars move independently through space. But these changes usually require tens of thousands of years to become noticeable. In a universe undergoing some vast rotational transformation, astronomers might observe movements that differed from familiar expectations. Star maps passed down through generations could require increasingly complex corrections. Space agencies and observatories would likely launch ambitious projects dedicated to understanding the phenomenon. Enormous telescopes orbiting far from Earth would compare observations gathered across centuries. Artificial intelligence systems might analyze unimaginable amounts of information, searching for hidden relationships invisible to human eyes. International collaborations would emerge, bringing together physicists, mathematicians, engineers, and philosophers in pursuit of answers. News of these discoveries would spread gradually. At first, the subject might remain confined to scientific journals and specialized conferences. Most people would hear little about it. But as evidence accumulated, public fascination would grow. Documentaries, books, and discussions would explore the possibility that humanity was witnessing a transformation unlike anything previously imagined. Naturally, not everyone would interpret the findings in the same way. Some individuals would propose exotic theories. Others would remain skeptical. Throughout history, new discoveries have often challenged established beliefs and inspired lively debates. The realization that Earth revolves around the sun once transformed humanity's understanding of its place in the cosmos. Discoveries concerning the age of the universe and the existence of distant galaxies expanded that perspective even further. An upside-down universe would represent another profound shift in how people viewed reality. Interestingly, the emotional response might not be fear. Human beings possess an extraordinary capacity to adapt. People living near active volcanoes continue building communities. Sailors venture across vast oceans. Astronauts willingly travel into space. Curiosity often proves stronger than anxiety. If the transformation unfolded slowly enough to avoid immediate danger, many people might experience wonder rather than panic. Artists would paint new visions of the heavens. Writers would compose stories inspired by the changing cosmos. Musicians might create compositions reflecting humanity's evolving understanding of existence. Philosophers would revisit ancient questions about direction, orientation, and the nature of reality. Religions and spiritual traditions might interpret the phenomenon through their own perspectives, adding new layers of meaning to humanity's collective experience. Meanwhile, children born into this era would grow up regarding these mysteries as normal, just as modern generations accept black holes, galaxies, and the expansion of space as ordinary facts. Future generations might inherit a universe whose subtle transformation had become part of everyday understanding. What once seemed unimaginable would gradually become familiar. Perhaps the most remarkable aspect of this scenario is how quietly it might unfold. No explosions would announce the beginning. No cosmic alarms would sound. Instead, humanity would encounter the change the same way it has encountered many of nature's deepest truths, through patience, observation, and a growing awareness that the universe is always larger and stranger than it first appears. Underneath the ordinary routines of life, beyond the blue sky and the distant stars, a gentle and almost imperceptible shift could be taking place, one so vast that entire civilizations might only glimpse small pieces of it. And in that quiet mystery, humanity would once again find itself doing what it has always done best, looking upward into the darkness and asking questions that stretch far beyond the limits of everyday experience. Long before human beings built cities or studied the stars with telescopes, the Earth and the Moon were already engaged in a quiet cosmic dance. Their relationship has lasted for billions of years, shaping the tides, influencing the length of days, and providing the steady rhythms that countless forms of life have come to depend upon. If the universe itself gradually began turning upside down, one of the first places scientists would examine would be this ancient partnership between our planet and its faithful companion. From the perspective of everyday life, the motions of Earth appear simple. The sun rises each morning and sets each evening. The moon changes shape throughout the month. Seasons arrive and depart with dependable regularity. Yet beneath these familiar experiences lies a remarkable collection of movements occurring simultaneously. Earth spins around its axis once every 24 hours. It travels around the sun at incredible speed. The moon circles Earth. Together, both worlds move through the Milky Way galaxy, while the galaxy itself journeys through the larger universe. Despite these astonishing motions, everything feels calm because the movements are smooth and consistent. Human beings notice change most easily when something accelerates suddenly or behaves unexpectedly. The Earth has maintained its rhythms so reliably that life evolved around them. Birds migrate according to seasonal patterns. Plants respond to daylight. Ocean creatures synchronize their activities with lunar cycles. Even the sleeping habits of many species are connected to these celestial motions. If the larger structure of the universe slowly began changing orientation, Earth's own movements might initially remain unaffected. The planet would continue spinning. Days and nights would still alternate. Seasons would continue their familiar progression. The moon would maintain its orbit. For generations, life could proceed almost exactly as before. Yet over immense spans of time, subtle differences might begin appearing in ways that only careful measurements could reveal. Astronomers have been studying the moon with remarkable precision for decades. Mirrors placed on the lunar surface by astronauts allow scientists to bounce laser beams off them and measure the moon's distance with extraordinary accuracy. Through these observations, researchers know that the moon is slowly drifting away from Earth by a few centimeters each year. This process has been unfolding for hundreds of millions of years and will continue far into the future. In a universe experiencing some vast rotational transformation, scientists would watch for deviations from these expected trends. Perhaps the moon's orbit would exhibit tiny irregularities. Perhaps Earth's rotation would change in ways that existing models struggled to explain. Such effects might be incredibly small, requiring centuries of observations before clear patterns emerged. The relationship between Earth and the moon is surprisingly delicate. The moon stabilizes the tilt of Earth's axis, helping to maintain relatively stable climates over long periods. Without the moon, Earth's orientation might vary much more dramatically, producing extreme changes in weather and seasons. Many scientists believe that this stability played an important role in the development of complex life. Because of this, even slight alterations in celestial mechanics would attract enormous attention. Scientists around the world would compare historical records spanning generations. Ancient eclipse observations, preserved by civilizations thousands of years ago, would become valuable sources of information. Data gathered by satellites and space probes would be analyzed with unprecedented care. Every tiny discrepancy could offer clues about the larger transformation unfolding throughout the cosmos. Interestingly, human beings have experienced changes in orientation before, although on much smaller scales. Earth's axis slowly wobbles over time through a process called precession. This motion causes the identity of the North Star to change over thousands of years. Ancient Egyptians saw different stars occupying positions that modern observers associate with Polaris. These gradual changes are so slow that individual lives rarely notice them. Yet over long periods, they become unmistakable. Future generations living in an upside-down universe might encounter something similar. Grandparents and grandchildren could share stories about the sky that seemed almost identical, while historians studying records spanning thousands of years would recognize a deeper transformation. Time itself would become an important ingredient in understanding the phenomenon. The oceans would also continue responding to the moon's gravity. Tides would rise and fall with familiar regularity. Coastal ecosystems would maintain their ancient rhythms. Fishermen would still plan their activities according to lunar cycles. The moon has served as a natural clock for countless species, and its gentle influence reaches far beyond the night sky. For many cultures throughout history, the moon has carried profound emotional and symbolic significance. It appears in myths, poetry, music, and stories from every corner of the world. People have gazed upon its changing phases for thousands of years, finding comfort in its predictable presence. In times of uncertainty, familiar celestial patterns often provide reassurance. If humanity gradually realized that the larger universe was changing orientation, the continued reliability of the moon and Earth might become a source of stability. Even while confronting mysteries of unimaginable scale, people would still witness moonlight reflecting upon oceans. Children would still marvel at lunar eclipses, and lovers would still walk beneath the same glowing companion that has accompanied humanity since the dawn of history. Perhaps this continuity would reveal something important. The universe often changes through patience rather than drama. Mountains rise slowly. Stars evolve gradually. Galaxies drift through space over billions of years. Nature rarely rushes. Instead, it unfolds with quiet persistence, allowing life to adapt and flourish within its rhythms. And so, even if the cosmos itself were undergoing some extraordinary transformation, the Earth and the Moon might continue their ancient dance with remarkable grace. Their partnership, forged across unimaginable ages, would remain one of the most familiar and comforting sights available to a species that has always looked upward and found wonder in the gentle light of the night sky. For most people, the universe feels very far away. Galaxies exist at unimaginable distances. Black holes inhabit remote regions of space, and the grand motions of the cosmos seem disconnected from everyday life. Yet, life on Earth depends upon delicate systems that surround us constantly. The air we breathe, the oceans that cover most of the planet, and the weather patterns that shape each season are all products of countless interactions that have been developing for billions of years. If the universe slowly began turning upside down, humanity would naturally wonder whether these familiar systems might eventually respond. At first glance, the answer would probably be reassuring. Oceans would not suddenly pour into the sky. Clouds would not fall into the ground. Birds would not begin flying beneath the earth. Such dramatic images belong more to dreams and stories than to the patient workings of nature. The forces governing the atmosphere and the seas are deeply tied to gravity, temperature, and the rotation of our planet. As long as those local conditions remained stable, life on Earth could continue much as it always had. The oceans themselves are among the oldest features of our world. Some of the water covering Earth today may have existed for billions of years. Generations of creatures have lived and disappeared beneath the waves, while continents shifted and mountains rose. The seas possess rhythms so ancient that they connect the present to the earliest chapters of planetary history. Every day, winds sweep across the surface of the oceans, transferring energy from the atmosphere to the water below. Currents carry heat around the globe, helping regulate climates and creating environments where life can flourish. The Gulf Stream, for example, transports warm water across the Atlantic Ocean and influences weather patterns far beyond its immediate surroundings. Similar currents operate throughout the world, quietly shaping temperatures and ecosystems. If the larger universe gradually changed orientation over immense periods, these systems would likely remain remarkably resilient. Nature is filled with processes that adapt slowly to changing conditions. Forests adjust to climate shifts. Species evolve over generations. Rivers carve new paths. Life has survived ice ages, asteroid impacts, volcanic catastrophes, and countless other challenges. Compared to these events, a slow cosmic transformation might initially have little effect upon the oceans themselves. Still, scientists would remain curious. They would ask whether tiny changes in Earth's motion or orientation could eventually influence atmospheric circulation. Even small variations in planetary conditions can produce long-term consequences. The length of seasons, the distribution of sunlight, and the tilt of Earth's axis all play important roles in shaping climate. Subtle changes accumulating over thousands or millions of years might slowly alter weather patterns in ways that future civilizations would carefully study. The atmosphere surrounding Earth is an extraordinary creation. Although it extends hundreds of kilometers into space, most of the air people depend upon exists within a relatively thin layer. This fragile blanket protects life from harmful radiation, regulates temperature, and allows water to cycle endlessly between oceans, clouds, and land. Without the atmosphere, Earth would resemble the barren surfaces of many other worlds. Weather itself emerges from countless interactions occurring simultaneously. Warm air rises while cooler air sinks. Moisture condenses into clouds. Winds distribute heat across continents. Storms form and dissipate. Snow blankets mountains. Rain nourishes forests. These processes seem chaotic, yet they operate according to patterns that scientists have spent centuries trying to understand. Imagine future generations living during an era when astronomers had become convinced that the universe was slowly turning upside down. Meteorologists and climate researchers would undoubtedly join the effort to understand whether any subtle influences could eventually reach Earth's atmosphere. Satellites would monitor clouds with astonishing precision. Supercomputers would analyze centuries of weather records. Every anomaly, every unusual trend would be examined for clues. Most likely, many of these investigations would reveal that Earth's weather remains primarily governed by local conditions. The sun would continue providing energy. Oceans would continue storing and distributing heat. Mountain ranges would still influence wind patterns. Familiar seasonal cycles would persist. Daily life would continue, and ordinary people might notice little difference. Perhaps the greatest lesson hidden within Earth's atmosphere is its ability to create beauty from constant change. Clouds never remain fixed. Winds never stop moving. Storms arise and disappear. Yet despite this endless motion, there exists an underlying balance that has supported life for vast stretches of time. Change does not necessarily mean chaos. Sometimes change itself becomes part of stability. The oceans tell a similar story. Waves endlessly crash upon shores. Tides rise and fall. Currents shift and wander. Yet the seas maintain a continuity that spans ages. A person standing beside the ocean today experiences something not entirely different from what ancient sailors, prehistoric creatures, and future generations may encounter. Water remains water. The rhythms endure. Human beings often imagine that stability requires stillness. Nature suggests otherwise. Stability can emerge from motion. Order can arise from change. The Earth itself spins constantly, yet people experience it as solid and dependable. Planets orbit stars. Stars orbit galactic centers. Galaxies move through the cosmos. Motion surrounds everything, and yet life flourishes within it. Even in a universe undergoing some unimaginably vast transformation, children would still jump into ocean waves, farmers would still watch the clouds, and people would still pause to admire sunsets painted across the evening sky. Rain would continue tapping softly upon windows. Snowflakes would drift through winter air. Thunderstorms would rumble across distant horizons. The ordinary wonders of Earth would remain companions to humanity, reminding everyone that even with changing universe, familiar beauty can endure with quiet grace. And perhaps, beneath the endless movement of winds and waves, there would be something deeply comforting. The realization that life has always existed within a universe in motion, and that the gentle patterns of Earth may continue long after human imagination has learned to accept that even the cosmos itself is capable of changing in ways far stranger and more beautiful than anyone once believed. For thousands of generations, human beings have looked upward during quiet evenings and found comfort in the stars. Long before cities filled the landscape with artificial lights, the night sky was one of the most familiar sights in existence. Ancient hunters followed seasonal constellations. Sailors crossed oceans by reading the stars. Poets, philosophers, and dreamers found inspiration in the countless points of light scattered across the darkness. Even today, despite all the technologies of the modern world, there remains something deeply peaceful about standing beneath the heavens and simply looking upward. If the universe itself slowly began turning upside down, one of the first questions many people would ask is surprisingly simple. Would the sky above us begin to look different? Would familiar constellations disappear? Would the moon rise in strange places? Would future generations gaze upon entirely new patterns of stars? At first, the answer would likely be no. The heavens would appear almost unchanged. The stars that people know and love would continue shining with the same gentle light. Orion would still dominate winter evenings. The Big Dipper would still guide observers across the northern sky. The Milky Way would continue stretching across dark landscapes like a river of distant suns. Ordinary nights would remain wonderfully familiar, yet the night sky has never been truly fixed, even though the stars appear permanent. They are all moving. Every star in the galaxy travels through space with its own velocity and direction. The reason these motions are difficult to notice is because the distances involved are enormous. Human lifetimes are short compared to cosmic timescales. What seems unchanging across decades may transform completely across hundreds of thousands of years. Imagine showing today's night sky to someone living 1 million years in the future. They would recognize many of the same stars, but the constellations themselves would look different. Familiar patterns would slowly distort. Some stars would move closer together. Others would drift apart. New arrangements would emerge. The sky, though still beautiful, would tell a slightly different story. An upside-down universe could add another layer to this gradual evolution. If the larger structure of space itself were changing orientation over immense periods, astronomers might notice subtle shifts beyond those already expected. Constellation maps preserved by ancient civilizations would become precious historical records. Future scientists might compare them with observations gathered over countless generations, searching for tiny clues hidden within the changing heavens. Ancient people often imagined that the stars were fixed upon enormous celestial spheres. These invisible shells were thought to rotate around the Earth, carrying the planets and constellations with them. Such ideas made sense because the heavens seemed perfectly ordered and stable. The stars returned year after year with remarkable reliability, creating the impression of permanence. Modern astronomy revealed something far more astonishing. Every visible star is a sun. Many possess planets. Entire galaxies containing hundreds of billions of stars drift through the depths of space. The universe is not a static picture hanging overhead, but an ever-changing landscape filled with movement on scales that exceed ordinary imagination. Suppose future astronomers observed that the Milky Way itself appeared to slowly rotate in unexpected ways. The bright band of stars crossing the sky could gradually shift over thousands or millions of years. Regions that once dominated certain seasons might migrate to different positions. Southern and northern skies could evolve in ways that transformed the cultural traditions associated with them. Human civilizations have always woven stories around the stars. Constellations became heroes, animals, and mythical creatures. Farmers used them to track planting seasons. Travelers relied on them for navigation. Entire calendars emerged from celestial observations. If the sky changed slowly enough, cultures would adapt. New constellations would receive new names. Old myths would merge with fresh interpretations. Humanity's relationship with the heavens would continue evolving as it always has. Future artists might paint the changing Milky Way with awe and wonder. Musicians could compose works inspired by the gradual transformation of the stars. Writers would create stories about ancestors who saw different skies. Children would learn that the heavens visible to their grandparents were not exactly the same as those above them. Change would become part of tradition. Even today, people living in different regions of Earth experience different skies. Someone standing in Iceland sees stars that remain forever hidden from observers in Australia, and vice versa. Yet both individuals share the same universe. Their perspectives differ, but the underlying reality remains connected. This reminds us that orientation and appearance are often matters of viewpoint, rather than absolute truths. Astronomers would undoubtedly become some of the most careful witnesses of an upside-down universe. Giant telescopes positioned on distant worlds and in deep space would observe the heavens continuously. Their records, accumulated across centuries, would preserve a cosmic history unlike anything humanity had previously known. Entire generations of scientists might dedicate their lives to understanding subtle changes that unfolded too slowly for ordinary experience to detect. For most people, however, the night sky would continue serving its timeless role. It would remain a source of peace. Families would gather beneath meteor showers. Campers would lie beside quiet lakes and count stars reflected in still water. Children would ask questions that have echoed across history. What are those lights? How far away are they? Are we alone? Perhaps that is one of the most beautiful things about the heavens. Even while the universe itself changes, the experience of wonder remains remarkably constant. Ancient shepherds, medieval sailors, modern astronomers, and distant future civilizations all share the same instinctive desire to look upward and seek meaning among the stars. And so, if the universe slowly turned upside down, the transformation might not announce itself with terrifying spectacles. Instead, it could reveal itself through quiet changes spread across ages, written gently into the patterns of the night sky. Generations would come and go beneath those stars, and through all those years, the heavens would continue offering what they have always given to humanity: mystery, beauty, and the comforting reminder that we are participants in something far larger than ourselves. Every morning, long before most people wake, sunlight begins its journey across the atmosphere of Earth. Birds stir in forests, oceans reflect golden colors, and another ordinary day quietly begins. For billions of years, the sun has provided warmth, light, and energy to our planet. Around it, the planets have continued their endless journeys, following paths established long before humanity appeared. If the universe itself slowly began turning upside down, one of the most important questions would naturally concern this familiar family of worlds. The solar system may appear peaceful, but it is constantly in motion. Mercury races around the sun with astonishing speed. Venus rotates so slowly that one day on its surface lasts longer than its year. Earth spins steadily while carrying oceans and continents through space. Mars experiences changing seasons and dust storms. Farther outward, the giant planets dominate the darkness with enormous storms and vast collections of moons. Despite these differences, every planet shares one common feature. They are all held together by the gravity of the sun. This invisible force acts like a quiet architect, maintaining order across billions of kilometers. Without it, the solar system would not exist. The planets would drift away into the depths of space, and the familiar rhythms that have governed life on Earth would disappear. If the larger universe gradually changed orientation, the sun itself would almost certainly continue behaving normally for an extraordinarily long time. Deep within its core, hydrogen atoms would continue combining and releasing energy. Light would continue streaming outward. The sun would rise and set from Earth's perspective. Seasons would continue their cycle, and life could proceed without noticing anything unusual. In fact, stars are remarkably stable objects. The sun has already existed for approximately 4.5 billion years, and it still has billions more years ahead of it. Throughout this immense span, it has endured countless events occurring elsewhere in the galaxy. Nearby stars have been born and died. Entire spiral arms have shifted. Yet the sun has remained a dependable source of energy for the worlds that orbit around it. The planets themselves possess a surprising variety of orientations. Uranus, for example, rotates in a way that appears strange compared to most other planets. Its axis is tilted so dramatically that it almost seems to roll through space rather than spin upright. For decades, this unusual configuration fascinated astronomers because it demonstrated that the universe has no requirement for worlds to align themselves according to human expectations. If one planet can possess such an unexpected orientation and still remain stable, perhaps a slowly changing universe would not immediately threaten the harmony of the solar system. Planets might continue their journeys almost unaffected, carried gently along by whatever larger transformation was unfolding throughout space. Future astronomers would certainly study planetary motions with extraordinary precision. Spacecraft positioned across the solar system would monitor every subtle change. Tiny variations in orbital paths would become subjects of intense interest. Computers far beyond anything existing today would compare observations spanning thousands of years. Entire scientific institutions might dedicate themselves to understanding whether the changing orientation of the universe was influencing the planets in any measurable way. Humanity's knowledge of planetary motion has always grown through patience. Ancient civilizations tracked wandering points of light and recorded their movements with remarkable care. Centuries later, those observations helped reveal that Earth itself travels around the sun. The discoveries seemed revolutionary because they challenged deeply held assumptions. A slowly turning universe might inspire similar moments of realization for future generations. Perhaps over millions of years, subtle differences would emerge. The orientation of planetary orbits might shift ever so slightly. The position of the solar system within the galaxy could gradually change. New patterns invisible to earlier civilizations might become apparent. These transformations would not resemble sudden disasters. Instead, they would unfold with the same calm persistence that characterizes much of nature. Meanwhile, life on Earth would continue beneath the familiar sunlight. Children would still draw pictures of the sun. Farmers would still depend upon the seasons. Travelers would still admire colorful sunsets. The warmth of sunlight on human skin would remain one of life's simplest pleasures. Most people would experience no direct evidence of the larger cosmic transformation occurring beyond the limits of ordinary perception. The planets themselves offer reminders that nature embraces diversity. Mercury circles close to the sun. Venus possesses crushing clouds. Earth supports life. Mars preserves ancient landscapes. Jupiter contains storms larger than entire worlds. Saturn surrounds itself with magnificent rings. Uranus spins at an unusual angle. Neptune circles in the distant darkness. Yet, despite these extraordinary differences, they coexist peacefully within the same system. This harmony suggests something profound. Stability does not require perfect uniformity. The universe is capable of maintaining order while allowing countless variations to exist simultaneously. Perhaps a changing orientation on the largest scales would simply become another example of this remarkable flexibility. As future civilizations gazed upward, they might discover that the sun and the planets had become symbols of continuity. In a universe whose deeper structure was gradually revealing new mysteries, the solar system would remain a familiar home. Its worlds would continue their ancient dance around the sun, just as they had done for billions of years. And somewhere in the quiet darkness between the planets, far from Earth's oceans and clouds, spacecraft and observatories would patiently gather information, searching for answers hidden within motions so vast and slow that entire civilizations might pass before their full significance became clear. Through it all, the sun would continue shining, indifferent to human worries, illuminating the worlds around it with the same gentle light that has accompanied life since its earliest beginnings. Far beyond the orbit of Mars, where sunlight grows weaker and temperatures fall to extraordinary lows, the solar system begins to feel very different. Here reside the giant worlds, enormous planets so vast that they seem more like miniature systems than individual objects. Jupiter, Saturn, Uranus, and Neptune have fascinated astronomers for centuries because they reveal just how diverse and unusual planetary environments can become. If the universe itself slowly started turning upside down, these distant giants might provide some of the most interesting clues about the transformation. Jupiter is by far the largest planet in the solar system. More than 1,000 Earths could fit inside its immense volume. Its powerful gravity influences asteroids, comets, and even the motions of neighboring planets. Storms larger than Earth rage across its atmosphere, including the famous Great Red Spot, a gigantic vortex that has persisted for centuries. Despite its chaotic appearance, Jupiter is an incredibly stable world, spinning rapidly and maintaining its position with remarkable consistency. If the larger universe began changing orientation, Jupiter would likely continue behaving much as it always has. Its clouds would continue swirling. Lightning would flash within deep atmospheric layers. Its many moons would follow their familiar paths. Yet because of its enormous mass, astronomers would study Jupiter carefully, searching for any tiny deviations that might reveal hidden changes occurring throughout space. Saturn presents an entirely different kind of beauty. Its magnificent rings have inspired wonder ever since telescopes first revealed them. Billions of particles of ice and dust orbit the planet in delicate patterns, creating one of the most breathtaking sights in the solar system. Future observers living in a slowly changing universe might wonder whether these rings could serve as natural indicators of subtle cosmic influences. Because Saturn's rings are so finely structured, even small disturbances can create visible patterns. Moons produce waves and gaps throughout the rings. Gravitational interactions shape their appearance. Scientists might spend centuries analyzing these structures, hoping to detect evidence of changes so slight that no ordinary instrument could easily measure them. The rings themselves could become enormous laboratories suspended in space. Then there is Uranus, perhaps the strangest of the giant planets. Unlike most worlds, Uranus rotates on its side. From certain perspectives, it appears almost to roll around the sun rather than spin upright. This unusual orientation may have been caused by a colossal collision early in the history of the solar system. Whatever the reason, Uranus demonstrates something remarkable. A world can possess an orientation that seems bizarre to human observers and still remain stable for billions of years. In some ways, Uranus already resembles an upside-down planet. Its seasons are unlike those experienced anywhere else in the solar system. For long periods, one pole faces the sun while the other remains in darkness. Yet, despite these extreme conditions, Uranus continues its quiet journey around the Sun without complaint. Future generations contemplating an upside-down universe might see Uranus as proof that orientation itself is often less important than human intuition suggests. Neptune, the most distant giant planet, occupies a realm of deep cold and faint sunlight. Although it lies billions of kilometers from the Sun, its atmosphere hosts some of the fastest winds known. Giant storms emerge and disappear, while unseen heat from the planet's interior contributes to its restless behavior. Neptune reminds astronomers that even in the most remote regions, nature remains active and dynamic. Together, these four giant worlds possess more than 100 moons. Some of these moons are extraordinary places in their own right. Europa may conceal an ocean beneath its icy shell. Titan possesses lakes and rivers made not of water but of liquid methane. Enceladus sprays great plumes of ice into space. Triton travels around Neptune in an unusual direction, hinting at a mysterious past. Each moon represents a unique environment shaped by billions of years of cosmic history. If the universe slowly changed orientation, these moons would likely continue their dances around their parent planets. Future space probes might monitor them continuously, searching for subtle effects that accumulated over enormous periods. Entire colonies of scientists living among the outer planets might dedicate themselves to studying these distant worlds and the clues they contained. The giant planets also act as guardians of the inner solar system. Their powerful gravity captures or deflects many comets and asteroids that might otherwise threaten Earth. Jupiter, in particular, plays a major role in shaping the architecture of the solar system. Without the giant planets, the history of life on Earth might have unfolded very differently. Perhaps that is one of the most beautiful lessons offered by these enormous worlds. They reveal that stability and strangeness often exist side by side. Jupiter's storms, Saturn's rings, Uranus's unusual tilt, and Neptune's powerful winds all seem exotic, yet they are perfectly natural parts of the universe. What appears strange from one perspective may simply be another expression of cosmic order. Millions of years into the future, civilizations spread across the solar system might regard these giant planets with the same affection ancient humans once reserved for the moon. Travelers living around Saturn's rings or above the clouds of Jupiter could grow accustomed to environments that earlier generations would have considered impossible. They might gaze into the heavens and wonder whether the universe itself was slowly turning upside down, while around them, the giant worlds continued their majestic rotations, largely unchanged by the concerns of those who studied them. In the endless darkness beyond Mars, where sunlight becomes pale and the stars shine with remarkable clarity, the giant planets would continue their patient revolutions. Their storms would rage, their moons would circle faithfully, and their mysteries would deepen. And as the universe quietly pursued whatever grand transformation lay hidden within its vastness, these enormous worlds would stand as reminders that the cosmos has always been stranger, more diverse, and more beautiful than human imagination first assumes. Beyond the giant planets, the solar system begins to open into a vast and quiet frontier where sunlight is weak, distances are enormous, and time feels almost suspended. This region is filled with countless small bodies, icy travelers, rocky fragments, and ancient remnants from the earliest days of planetary formation. Comets, asteroids, and distant objects may seem insignificant compared to planets, yet they hold some of the most important clues about the history and structure of the solar system. In a universe slowly turning upside down, these small wanderers could become some of the first places where subtle changes begin to reveal themselves. Asteroids are rocky objects that mostly reside between Mars and Jupiter, although many exist in other regions as well. Some are small, no larger than pebbles, while others stretch hundreds of kilometers across. They are not arranged in neat formations, but instead occupy a wide belt of scattered orbits, each following its own path around the sun. Over billions of years, these rocks have remained largely unchanged, preserving material from the early solar system like time capsules floating in space. Comets, on the other hand, are icy bodies that originate from the distant edges of the solar system. When a comet approaches the sun, it begins to warm, releasing gas and dust that form a glowing coma and a long tail that always points away from the sun due to solar wind. These brilliant visitors appear periodically in the night sky, sometimes becoming bright enough to be seen without telescopes. Ancient civilizations often interpreted them as signs or omens, unaware that they are simply natural travelers on elongated orbits shaped by gravity. If the universe itself slowly began changing orientation, comets and asteroids would likely continue their motions without immediate disruption. Their orbits are governed by gravity, and gravity operates locally. Each object responds primarily to the sun and nearby planets, not to any distant structure of space. For this reason, the early stages of a cosmic transformation might pass unnoticed among these small bodies. However, comets are particularly sensitive to small influences. A slight change in temperature, gravitational tug, or radiation pressure can alter their paths over time. As they travel through the outer regions of the solar system, even tiny forces accumulate across millions of kilometers. Future astronomers might pay special attention to comets as natural indicators of subtle changes in the environment of space itself. The asteroid belt between Mars and Jupiter presents another fascinating environment. Although often imagined as a crowded field of rocks, it is in reality mostly empty space. Each asteroid is separated by vast distances. Spacecraft can travel through the belt without encountering any objects at all. Yet within this emptiness lies a dynamic system influenced by the gravity of Jupiter. Over long periods, asteroid orbits shift, collide, and evolve. If a universe-wide transformation were occurring, scientists might search for unusual patterns within this belt. Perhaps certain asteroid families would begin showing unexpected alignments. Perhaps collision rates would change slightly. These differences would likely be extremely subtle, requiring careful long-term study to detect. But the asteroid belt, like a slowly ticking clock, could preserve evidence of changes unfolding across cosmic timescales. Far beyond Neptune lies one of the most mysterious regions of the solar system. The Kuiper Belt is a vast collection of icy bodies, dwarf planets, and ancient remnants that orbit the sun at extreme distances. Objects such as Pluto, Eris, and countless smaller worlds reside here in darkness and cold. Even farther out, scientists believe there may exist a spherical cloud of icy objects surrounding the solar system, known as the Oort cloud, from which long-period comets originate. These distant regions are so far from the sun that changes occur incredibly slowly. A single orbit can take thousands or even millions of years. Because of this, they act as archives of the solar system's earliest history. If the universe were changing orientation, these outer regions might be among the last places where effects became visible. Their extreme distances make them both fragile and revealing, like quiet observers watching the rest of the solar system from afar. Human exploration of these regions has only just begun. A handful of spacecraft have crossed into the outer solar system, sending back faint signals from the edge of the sun's influence. Future missions might travel deeper into these distant territories, mapping objects that have never been seen before. Scientists of future generations might build entire observatories dedicated to studying these remote icy worlds, searching for patterns hidden in their slow movements. Comets entering the inner solar system might become especially important. As they travel inward, they pass through multiple gravitational environments, interacting with planets and solar radiation. If subtle changes were occurring in the structure of space itself, comets could act like sensitive instruments tracing those variations. Their elongated paths might contain traces of information written across millions of years of travel. Yet despite their importance, these objects would continue their journeys quietly. Comets would still flare as they approached the sun. Asteroids would still drift through the darkness. Distant icy worlds would still orbit in silence. From the perspective of everyday life on Earth, nothing dramatic would be immediately visible. The universe would continue appearing stable, familiar, and unchanged. And still, beneath that calm surface, the small bodies of the solar system would continue their endless motion, preserving ancient history while carrying subtle clues about a much larger cosmic story. In their quiet paths through space, they would remind future observers that even the smallest objects can become important witnesses to changes that unfold across unimaginable scales of time and distance. When people look at the night sky, stars appear as tiny, steady points of light. They seem fixed, almost permanent, as if they were carefully placed across a dark surface. Yet every star is a massive, burning sphere of plasma, constantly moving, rotating, and evolving over time. In a universe slowly turning upside down, stars would play a central role in revealing how deeply perspective and orientation depend on scale and motion, rather than any absolute direction. Each star in the galaxy is in motion. Some move in gentle orbits around the center of the Milky Way, while others travel at high speeds on more unusual paths. These motions are invisible to the naked eye because the distances are so vast that even the fastest stellar movements take thousands of years to noticeably change the sky. From Earth, stars appear almost frozen, but in reality, they are part of a dynamic and constantly shifting system. If the universe itself were undergoing a gradual inversion, stars would likely continue shining without interruption. Their internal processes are governed by nuclear fusion, where immense pressure and temperature in their cores convert hydrogen into helium, releasing enormous amounts of energy. This process is deeply local. It does not depend on the orientation of space around the star. As a result, even if space were subtly changing its global structure, stars would continue burning in the same stable way for billions of years. However, astronomers might begin to notice subtle shifts in stellar positions over extremely long periods. The relative arrangement of stars could appear slightly different when compared with ancient star catalogs. Although stars already move naturally through the galaxy, a universe-wide transformation might introduce additional, extremely faint patterns in their motion. These changes would not be sudden or dramatic, but accumulated gradually across generations of observation. Stars themselves do not possess a universal sense of orientation. A star does not know whether it is upright or upside down. It exists in a state defined entirely by gravity, pressure, and internal equilibrium data. Its structure is spherical because gravity pulls matter inward equally from all directions. In this sense, every star is naturally symmetrical, without a preferred top or bottom. This symmetry becomes even more interesting when considering stellar rotation. Many stars spin on their axes, sometimes rapidly enough to flatten slightly at their equators. Some stars rotate in alignment with surrounding planetary systems, while others spin at unexpected angles. There is no universal rule that dictates how a star must be oriented in space. Each one reflects its own formation history, shaped by local conditions within the molecular clouds from which it was born. If the universe were slowly changing orientation, the concept of stellar alignment would become even more relative. Astronomers might begin to describe star systems not by absolute directions, but by relationships between local reference points. Instead of asking whether a star was upright, they would focus on how it behaved relative to surrounding objects. Just as navigation on Earth already depends on local coordinates rather than any universal up or down. Within the Milky Way, stars are distributed across a vast rotating disk. From a distance, this disk would appear like a luminous spiral filled with billions of suns. The galaxy itself rotates slowly, completing a full revolution over hundreds of millions of years. Stars nearer to the center move faster than those at the edges, creating a complex but orderly structure. Despite this motion, the galaxy maintains its overall shape with remarkable stability. Future civilizations, studying a changing universe, might compare current observations of the Milky Way with extremely ancient records preserved from earlier epochs. They might search for patterns that suggest slow alterations in the galaxy's orientation relative to other cosmic structures. These investigations would require extraordinary patience, as even the largest galactic changes unfold across timescales far beyond human experience. Beyond the Milky Way, countless other galaxies fill the universe. Some are spiral like our own, while others are elliptical or irregular in shape. Each galaxy contains its own collection of stars, moving according to local gravitational rules. From any given galaxy, observers would likely perceive themselves as being near the center of their observable universe. This creates a powerful illusion that has influenced human understanding for centuries. The idea that wherever one stands, the cosmos appears centered around that location. In a slowly transforming universe, this illusion of centrality would remain intact. Observers in distant galaxies would still see their surroundings as naturally oriented. Only by comparing data across immense distances and times would subtle differences emerge. These differences might suggest that something deeper was affecting the structure of space itself, even though no single observer could directly perceive the change. Despite their enormous energy output and dramatic life cycles, stars are remarkably patient structures. Some burn for billions of years with little visible change. Others end their lives in spectacular supernova explosions, scattering heavy elements across space to form new generations of stars and planets. This cycle of birth and death continues endlessly, ensuring that the universe remains active and evolving. Even if the universe were slowly turning upside down, stars would remain among its most reliable anchors. They would continue shining, rotating, and evolving according to the same physical laws that have governed them since their formation. Their light would still travel across vast distances, reaching planets like Earth and providing both illumination and wonder. And so, as civilizations look upward and attempt to understand the structure of reality, stars would continue offering a quiet reminder. Orientation may be relative, perspective may change, and cosmic structures may evolve over unimaginable timescales, but the fundamental processes that govern the lives of stars remain steady, patient, and deeply woven into the fabric of the universe itself. Deep within the galaxy, far from the calm appearance of the night sky, lie regions where stars are born. These vast clouds of gas and dust are called nebulae, and they are among the most visually striking structures in the universe. Some glow with soft reds and blues, illuminated by nearby stars, while others remain dark and dense, blocking light from passing through. In a universe slowly turning upside down, these stellar nurseries would continue their quiet and essential role in shaping the next generations of stars. Nebulae are not static objects. They are constantly moving, expanding, contracting, and interacting with surrounding forces. Gravity pulls material inward, forming dense pockets where new stars begin to ignite. At the same time, radiation from young stars pushes outward, sculpting intricate shapes in the surrounding gas. This balance between collapse and pressure creates regions of both creation and destruction, all happening simultaneously within the same vast clouds. The Orion Nebula is one of the most well-known examples of such a region, visible even to the naked eye under dark skies. It appears as a faint, glowing patch within the constellation of Orion. Through telescopes, it reveals a complex structure filled with young stars, hot gas, and swirling dust. These processes are ongoing, meaning that what is observed today is only a single frame in an extremely long and dynamic evolution. If the universe were undergoing a slow inversion of orientation, nebulae would likely continue forming stars without interruption. The processes that govern star formation are local in nature, depending primarily on gravity, temperature, and pressure within the clouds. These conditions would remain unchanged in any immediate sense, allowing stellar nurseries to function normally for vast periods of time. However, over immense timescales, astronomers might begin to examine whether the large-scale structure of nebulae revealed subtle differences. The shapes of gas clouds could appear slightly altered when compared across generations of observation. Filaments of dust might align in patterns that were not expected based on earlier models. These differences would be extremely faint, requiring precise instruments and careful analysis to detect. Nebulae often span hundreds of light years, meaning that light from one part of a cloud can take centuries to reach another region. Because of this, they naturally contain a kind of historical layering. Different parts of a nebula represent different moments in time in a universe slowly changing its global orientation. This layered structure might preserve traces of transformation in ways that would only become visible when studied across very long periods. Within these clouds, gravity gradually pulls material together. As density increases, temperatures rise, eventually leading to the ignition of nuclear fusion. A new star is born. This process has repeated countless times across the history of the universe, ensuring a continuous cycle of stellar life. The elements formed in previous generations of stars are recycled into new systems, eventually becoming part of planets, oceans, and even living organisms. This connection between nebulae and life itself is one of the most profound relationships in astronomy. The calcium in bones, the oxygen in air, and the carbon in living cells were all forged in ancient stars and distributed through nebulae long before Earth existed. Every new star system carries the potential for new worlds and new forms of complexity. In a changing universe, this cycle of creation would remain one of the most stable and enduring processes. Nebulae would continue to collapse, stars would continue to ignite, and planetary systems would continue to emerge. Even if the larger structure of space were subtly shifting over unimaginable spans of time, the basic rhythm of stellar birth would persist. Some nebulae are created by the death of stars. When massive stars reach the end of their lives, they explode in supernova events, releasing enormous amounts of energy and scattering heavy elements into surrounding space. These remnants become the raw material for future generations of stars. In this way, death becomes directly linked to creation, forming a continuous cycle that shapes the evolution of galaxies. If the universe were slowly turning upside down, these explosive events would still occur according to their own internal physics. The brightness and energy of supernovae are determined by conditions within the stars themselves, not by the orientation of space around them. As a result, they would continue serving as powerful markers in the night sky, visible across vast distances. Astronomers studying nebulae across different regions of the galaxy might eventually notice extremely subtle patterns. Perhaps certain structures would show faint asymmetries when compared to earlier observations. Perhaps large-scale distributions of gas would appear slightly shifted in ways that could not be easily explained. These clues would likely be difficult to interpret, but they might hint at deeper processes affecting the structure of space itself. Yet for most observers, nebulae would remain objects of beauty and wonder. Long exposure images would reveal glowing clouds shaped like wings, pillars, and flowing curtains of light. These images would continue inspiring curiosity, reminding viewers that the universe is not only vast, but also richly creative in its natural forms. In the quiet regions between stars, where gas drifts slowly through darkness and gravity patiently gathers matter into new forms, the universe would continue its ancient cycle of transformation. Even in a cosmos undergoing slow and almost imperceptible changes in orientation, the birthplaces of stars would remain active, steady, and essential. And so nebulae would continue to tell one of the most important stories in the universe. From chaos comes structure, from dust comes light. And from quiet clouds of gas emerge the stars that illuminate galaxies. In their slow and patient evolution, they would remain one of the clearest reminders that the universe is always in motion, always creating, and always unfolding in ways that extend far beyond immediate perception. The Milky Way galaxy is home to everything familiar in human experience: the sun, the planets, the night sky, and countless stars that stretch across the darkness in a soft, luminous band. From Earth, it appears as a glowing river of light arcing overhead, a reminder that our world is only one small part of a far larger structure. If the universe were slowly turning upside down, the Milky Way would become one of the most important scales for understanding how deeply such a transformation might reach. The galaxy itself is not a simple object. It is a vast rotating system containing hundreds of billions of stars, along with clouds of gas, dust, and dark matter that hold it together through gravity. Its shape is roughly that of a flattened disk with spiral arms extending outward from a dense central region. From above or below, it would resemble a slowly spinning wheel of light, turning over hundreds of millions of years. Everything within the Milky Way participates in this rotation. The sun orbits the galactic center, completing one full revolution in a time span so long that early human civilizations have existed for only a tiny fraction of it. Stars closer to the center move faster, while those farther out move more slowly, creating a complex but stable structure that has persisted for billions of years. If the universe itself were undergoing a gradual inversion of orientation, the Milky Way would not suddenly flip like a physical object in space. Instead, any change would likely appear as an extremely subtle alteration in how its structure is perceived or measured. Astronomers might begin to notice tiny inconsistencies in the expected motion of stars or in the distribution of matter across the galaxy. These changes would be so small that they would require centuries of careful observation to confirm. One of the most fascinating aspects of the Milky Way is that it already challenges human intuition about orientation. From Earth, observers see the galaxy as a band stretching across the sky. Yet this appearance is purely a result of our position inside it. If one could travel far above the galactic disk, the Milky Way would appear entirely different, revealing its spiral structure in full clarity. What seems like a flat band is actually a vast three-dimensional system filled with motion and depth. Within the galaxy, stars are not evenly distributed. Spiral arms contain regions of active star formation, while other areas are more sparsely populated. The sun resides in a relatively quiet region known as the Orion Arm. This location has been stable enough to allow life on Earth to develop over billions of years, shielded from some of the more chaotic regions closer to the galactic center. A slowly changing universe might subtly influence how these structures evolve over extremely long timescales. Spiral arms could shift their shapes slightly. The density of star-forming regions might vary in ways that only become noticeable across immense periods. Even the position of the solar system within the galaxy might change in ways that future astronomers would carefully track and analyze. Yet, despite these possibilities, the Milky Way would continue to function as a coherent system. Gravity would still bind its stars together. Gas clouds would still collapse to form new suns. Supernovae would still enrich space with heavy elements. The fundamental processes that shape the galaxy would remain steady, operating according to laws that appear remarkably consistent across time. One of the most intriguing challenges in studying a galaxy is perspective. Observers within the Milky Way cannot easily step outside it to view its full structure. Instead, they must reconstruct its shape using measurements of stellar positions, motions, and distances. This is similar to trying to understand the shape of a forest while standing among its trees. Each observation provides a piece of the larger puzzle, but the complete picture requires careful synthesis over long periods. If the universe were gradually shifting orientation, this challenge would become even more complex. Astronomers might need to distinguish between changes caused by local galactic motion and those arising from deeper, more universal transformations. Separating these effects would demand extraordinary precision and patience, as well as collaboration across generations of scientific study. The Milky Way also serves as a reminder that motion is everywhere. Stars orbit, clusters drift, and entire regions of the galaxy evolve over time. Even the concept of a fixed reference frame becomes difficult to define at such scales. Everything is moving relative to everything else, and yet patterns of structure and order remain visible. In a cosmic sense, the galaxy itself is both ancient and alive. It has existed for billions of years, but it continues to change, producing new stars while recycling the remnants of old ones. This continuous cycle gives the Milky Way a kind of slow rhythm, a pulse that extends far beyond human perception. If the universe were slowly turning upside down, that rhythm would likely continue uninterrupted. The galaxy would not lose its structure or coherence. Instead, any transformation would be layered on top of its existing motions, becoming part of a larger story that unfolds across unimaginable scales of time. For observers within the galaxy, the night sky would still shine with familiar patterns. Constellations would still appear. The band of the Milky Way would still stretch across the darkness. But hidden within that familiar view, astronomers might detect faint signs that something deeper was occurring, something that challenged the assumption that space itself was fixed and unchanging. And so the Milky Way would remain what it has always been, a vast, rotating island of stars drifting through the cosmos, stable enough to host countless worlds, yet dynamic enough to remind those who study it that even galaxies are part of a universe that never truly stands still. Although the Milky Way feels unimaginably vast, it is not alone. Beyond its spiral arms and billions of stars lies a larger family of galaxies known as the Local Group. This collection contains dozens of galaxies of various sizes, all bound together by gravity and slowly moving through the universe as members of a shared cosmic neighborhood. If the universe itself gradually began turning upside down, these neighboring galaxies would provide some of the clearest opportunities to observe the effects of such a transformation on scales far larger than individual stars or planetary systems. The nearest large companion to the Milky Way is the Andromeda Galaxy. Located more than 2 million light-years away, it is the most distant object visible to the naked eye under dark conditions. To ancient observers, it appeared merely as a faint patch of light. Modern telescopes, however, reveal it to be another magnificent spiral galaxy containing hundreds of billions of stars. In many ways, Andromeda resembles the Milky Way, though it is somewhat larger and more massive. For billions of years, these two giant galaxies have been slowly approaching one another. Their mutual gravity ensures that they are destined to collide and merge far in the future. Despite the dramatic word collision, individual stars are so widely separated that very few direct stellar impacts are expected. Instead, the galaxies will gradually blend together, creating a new and larger structure over immense spans of time. If the universe were slowly changing orientation, astronomers would naturally compare the motions of the Milky Way and Andromeda with extraordinary precision. Tiny differences in their trajectories might reveal clues that could not be detected within a single galaxy alone. By studying multiple systems simultaneously, scientists would hope to distinguish local effects from broader cosmic patterns. Surrounding these giant galaxies are numerous smaller companions. The Large Magellanic Cloud and the Small Magellanic Cloud are two such examples. Visible from the southern hemisphere, these irregular galaxies orbit the Milky Way and contain active regions of star formation. They appear as soft glowing patches in the night sky and have inspired wonder among observers for centuries. Dwarf galaxies are particularly interesting because they are highly sensitive to gravitational influences. Their shapes and motions can be altered by interactions with larger neighbors. In a slowly transforming universe, future astronomers might carefully examine these smaller systems, searching for delicate signs that something deeper was affecting the structure of space itself. The local group extends across millions of light years and contains more than 50 known galaxies. Yet even this collection represents only a tiny fraction of the observable universe. Beyond it lie galaxy clusters, superclusters, and enormous filaments of matter stretching across distances so vast that they challenge human imagination. From the perspective of an observer living inside one galaxy, neighboring galaxies may seem fixed and eternal. In reality, they are constantly moving. Their motions are slow, but they are not motionless. Over billions of years, gravitational interactions reshape entire galactic systems. Galaxies merge, stars are redistributed, and new structures emerge from old ones. Change is a fundamental characteristic of the cosmos. Imagine future civilizations possessing records that span millions of years. Such civilizations might notice patterns invisible to humanity today. They could compare the orientations of countless galaxies and identify subtle shifts occurring across enormous regions of space. These changes would not resemble sudden flips or dramatic inversions. Instead, they would appear as gentle trends unfolding with almost unimaginable patience. Interestingly, galaxies themselves possess no preferred direction. Some spin clockwise from our perspective, while others rotate counterclockwise. Some are tilted edge-on, while others present their spiral faces directly toward Earth. There is no cosmic rule requiring galaxies to align themselves in a particular orientation. Each system reflects its own unique history of formation and interaction. This diversity would likely continue even in an upside-down universe. Neighboring galaxies would maintain their individuality. Their stars would continue shining, their black holes would remain active, and their clouds of gas would continue forming new generations of suns. The universe has always displayed remarkable flexibility in accommodating a vast range of structures and orientations. Future astronomers might build observatories on worlds far beyond Earth, perhaps even between galaxies themselves. These instruments could monitor the local group with extraordinary accuracy, collecting data over timescales that dwarf recorded human history. Through such observations, they might uncover evidence that the entire group was participating in some larger cosmic motion, one extending beyond the familiar boundaries of individual galaxies. Yet, for ordinary observers living on planets scattered throughout these systems, daily life would likely remain unchanged. Sunrises would still occur, oceans would still rise and fall, children would still look upward and wonder about the stars. Most inhabitants would experience the universe as stable and familiar, unaware of the immense and subtle processes unfolding across distances measured in millions of light years. Perhaps this is one of the most remarkable aspects of reality. Events occurring on the largest scales do not necessarily disrupt the smaller scales where life exists. Galaxies may drift, clusters may evolve, and the universe itself may change orientation. Yet the quiet experiences of everyday existence can continue with extraordinary resilience. As the Milky Way and its neighbors journey together through the darkness, they form a cosmic community, bound not by fixed positions, but by relationships and motion. In a universe that never truly stands still, these neighboring galaxies would continue their ancient dance, offering future generations an ever deeper appreciation of the immense and beautiful structures that surround them. Among all the objects discovered by modern astronomy, few inspire as much curiosity as black holes. They cannot be seen directly. They hide their interiors from the rest of the universe, and they possess gravitational fields so powerful that even light itself cannot escape once it passes a certain boundary. For decades, black holes were viewed almost like cosmic monsters, mysterious and dangerous regions lurking in the darkness. Yet the more scientists have learned about them, the more they have come to understand that black holes are not cosmic accidents. They are natural parts of the universe, created through the ordinary life cycles of stars and the evolution of galaxies. If the universe itself slowly began turning upside down, black holes would occupy a unique position in the story. Their extreme properties make them some of the most stable and enduring structures in existence. While stars shine and eventually die, and while galaxies slowly change shape over billions of years, black holes can persist for timescales so vast that they almost seem eternal compared to the lifespan of civilizations. Most black holes form when very massive stars reach the ends of their lives. After exhausting their fuel, these stars can no longer support themselves against gravity. Their cores collapse inward, creating regions where matter becomes compressed to extraordinary densities. Surrounding these regions is the event horizon, a boundary beyond which nothing can return. To distant observers, the black hole appears as a dark object interacting with its surroundings only through gravity and the energetic material falling into it. But black holes are not simply stationary holes in space. Many of them rotate. In fact, some spin at incredible speeds. This rotation affects the space around them, producing effects so strange that they almost sound like science fiction. Space itself can become dragged around the black hole, twisting and swirling in a phenomenon known as frame dragging. Objects and radiation near the black hole are influenced by this rotational motion, creating some of the most exotic environments known to science. In a universe slowly changing orientation, these rotating black holes would become especially interesting. Since they already influence the geometry of space around them, future astronomers might wonder whether the larger transformation of the cosmos would somehow interact with these effects. Massive observatories spread across galaxies could monitor black holes with extraordinary precision, searching for tiny deviations in their behavior. At the centers of galaxies reside supermassive black holes, giants containing millions or even billions of times the mass of the Sun. The Milky Way itself hosts one such object at its center, although it remains relatively quiet compared to the active black holes found in some other galaxies. Its gravity helps shape the motions of stars throughout the galactic core. These enormous black holes are among the oldest structures in the universe. Some formed when the cosmos itself was still young. They have witnessed the birth and death of countless stars and the evolution of entire galaxies. In a slowly inverting universe, they would continue their silent existence, largely indifferent to the concerns of smaller objects and civilizations. Interestingly, black holes themselves do not possess an absolute sense of up or down. Like stars and galaxies, their orientations are defined only relative to surrounding matter. One black hole may spin in a direction that appears opposite to another. Some consume material through disks tilted at unusual angles. Others launch enormous jets of energy extending across thousands of light years. There is no universal orientation that all black holes obey. This fact reinforces one of the recurring themes of the cosmos. Direction is often a matter of perspective. Human beings naturally seek fixed reference points because everyday life on Earth provides them. But on cosmic scales, nature reveals an astonishing freedom. Objects spin, tilt, and move in every conceivable direction while remaining perfectly stable. Future civilizations might build observatories near black holes, using their immense gravitational fields to study the deepest mysteries of reality. Such instruments could analyze gravitational waves, measure distortions of space, and perhaps detect subtle signatures of a universe gradually changing orientation. Information gathered over millions of years might reveal patterns too delicate for shorter observations to uncover. Black holes also serve as reminders that some of nature's most mysterious objects are not necessarily violent. Popular imagination often portrays them as cosmic vacuum cleaners devouring everything nearby. In reality, most black holes spend much of their existence in relative quiet. A person standing far enough away from one would experience its gravity no differently than that of any other object with the same mass. Their reputation is more dramatic than their everyday behavior. As time passes, Black holes may even become some of the last surviving structures in the universe. Stars will eventually exhaust their fuel. Galaxies will evolve, but black holes could endure for unimaginably long periods, slowly releasing energy through processes that operate across timescales almost impossible to comprehend. If the universe truly were turning upside down over immense ages, black holes might become among its most patient witnesses. They would continue spinning, warping space around them, and silently influencing their surroundings. Their event horizons would remain invisible boundaries, hiding secrets that future generations would endlessly seek to understand. And perhaps there is something strangely calming about that image. Across billions and trillions of years, while stars are born and die, and galaxies drift through the darkness, these mysterious objects would remain, turning slowly within the vastness, reminding observers that even the most extreme regions of the cosmos are woven into the same grand and ever-changing universe that has surrounded humanity since the beginning of its journey. Beneath the stars, when people imagine the universe, they usually picture things that can be seen. Stars shining in the night sky, planets orbiting distant suns, glowing nebulae, and entire galaxies filled with light. These objects feel substantial and familiar because they emit or reflect radiation that telescopes can detect. Yet one of the most surprising discoveries of modern astronomy is that nearly everything visible may represent only a small fraction of what actually exists. Hidden throughout the cosmos is something scientists call dark matter. Unlike ordinary matter, dark matter does not appear to emit, absorb, or reflect light. It is invisible. No telescope can directly photograph it. No human eye could ever see it. And yet, despite its invisibility, astronomers are convinced that it exists because of the powerful influence it exerts through gravity. The first clues emerged when scientists studied the motions of stars within galaxies. According to calculations based only on visible matter, stars near the outer regions of galaxies should move more slowly than those closer to the center. Instead, observations revealed something unexpected. Stars far from the center were moving much faster than anticipated. It was as though some enormous invisible structure surrounded the galaxy, providing additional gravity and holding everything together. Without this unseen mass, many galaxies might not possess the shapes observed today. Spiral arms could disperse. Clusters of galaxies might separate. The universe would look very different. In many ways, dark matter acts like an invisible framework upon which visible structures are built. If the universe slowly began turning upside down, dark matter would become one of the greatest mysteries in understanding how such a transformation unfolded. Since dark matter already interacts with ordinary matter primarily through gravity, future astronomers might wonder whether it could reveal hidden aspects of the changing cosmos that visible matter alone could not. Unlike stars or planets, dark matter appears to form enormous halos surrounding galaxies. The Milky Way itself is believed to reside inside one of these invisible structures. Although humans cannot see this halo, every star and planet in the galaxy moves under its influence. In a sense, all known life exists within a vast ocean of unseen matter extending far beyond the visible boundaries of the galaxy. This idea can feel almost dreamlike. Entire structures larger than galaxies may surround us at every moment, completely unnoticed, except through their gravitational effects. The stars that people admire on clear nights represent only small islands of light embedded within much larger invisible systems. In a slowly changing universe, scientists might begin searching for tiny alterations in the distribution of dark matter. They would examine the motions of galaxies, study gravitational lensing, and compare observations gathered across immense periods of time. Gravitational lensing occurs when the gravity of massive objects bends light from more distant sources. By studying these distortions, astronomers can map the presence of dark matter even though it remains invisible. Future civilizations possessing technologies beyond anything available today might create detailed maps of these hidden structures. They could discover enormous filaments connecting galaxies across hundreds of millions of light years. They might find that the universe resembles an immense cosmic web, with visible galaxies shining like dewdrops upon invisible strands. If the orientation of the universe itself were changing, perhaps these structures would preserve subtle evidence of that transformation. Tiny asymmetries in the distribution of matter could slowly emerge. Patterns invisible to earlier generations might become apparent after millions of years of observation. The changes would not be dramatic. They would reveal themselves quietly, hidden within statistical relationships and delicate gravitational effects. Interestingly, dark matter itself does not seem concerned with direction. Just like stars and black holes, it possesses no obvious concept of up or down. Gravity acts equally in every direction. Structures form according to local conditions rather than some universal orientation. This recurring theme appears again and again throughout the cosmos. The universe cares remarkably little about the labels human beings assign to it. The existence of dark matter also serves as a humbling reminder. Despite centuries of scientific progress, humanity still understands only a fraction of reality. Entire components of the universe remain mysterious. Even now, scientists do not know precisely what dark matter is made of. Numerous possibilities have been proposed, but definitive answers remain elusive. Perhaps future generations will look back upon the present era much as modern people look back upon ancient astronomy. They may marvel at how much was still unknown. New discoveries could reveal properties of dark matter that transform humanity's understanding of space, gravity, and the evolution of the universe itself. Yet even in the absence of complete answers, dark matter performs its silent work. It guides galaxies. It shapes clusters. It influences the paths of stars and the formation of cosmic structures. Without ever producing a single ray of light, it has helped create the environments in which stars, planets, oceans, and living beings could emerge. And so, if the universe slowly turned upside down over unimaginable ages, this invisible substance would likely continue its quiet role. Hidden from direct view, stretching across vast regions of space, dark matter would remain one of the most mysterious and essential ingredients in the cosmic story. It would serve as a reminder that reality often extends far beyond what can be seen, and that some of the greatest forces shaping existence operate silently, patiently, and almost entirely in the shadows. For most of human history, people naturally assumed that the universe was either static or that gravity would gradually slow down its expansion. This expectation seemed reasonable. Gravity pulls things together. Planets orbit stars. Stars gather into galaxies, and galaxies attract one another. It appeared logical that the combined gravity of all matter in the cosmos would eventually act like a brake, causing the expansion of space to slow over time. Yet near the end of the 20th century, astronomers made a discovery that completely changed humanity's understanding of the universe. By studying distant exploding stars, they found evidence that the expansion of the universe is not slowing down. Instead, it is accelerating. Galaxies are moving away from one another faster and faster as time passes. Something mysterious appears to be driving this acceleration. Scientists call this unknown influence dark energy. The name itself reflects how little is truly understood about it. Unlike ordinary matter, and unlike dark matter, dark energy does not seem to gather into stars or galaxies. Instead, it appears to be spread throughout space itself, quietly influencing the entire cosmos. Today, many cosmologists believe that dark energy makes up most of the universe. Ordinary matter, the material that forms stars, planets, mountains, oceans, and living creatures, represents only a small fraction of the total cosmic inventory. In a strange sense, everything familiar exists within a universe dominated by components that remain largely mysterious. If the universe slowly began turning upside down, dark energy would immediately become one of the most important subjects of investigation, because it appears to be connected to space itself. Any large-scale transformation involving the orientation or structure of the cosmos might somehow involve dark energy as well. Future astronomers would likely ask fascinating questions. Could dark energy respond differently if the geometry of the universe changed? Might it strengthen, weaken, or remain completely unaffected? Could subtle variations in its behavior leave clues that reveal the deeper nature of reality? These questions would challenge generations of scientists and philosophers alike. One remarkable aspect of dark energy is its uniformity. Observations suggest that it acts similarly throughout enormous regions of space. Whether one examines nearby galaxies or structures billions of light years away, the expansion of the universe appears astonishingly consistent. This smoothness gives the cosmos a kind of hidden order despite its immense complexity. Imagine a future civilization with observatories spread across many galaxies. Such civilizations might collect data over millions of years, comparing the expansion of different regions with extraordinary precision. Tiny irregularities invisible to humanity today could become measurable. If the universe were gradually changing orientation, perhaps dark energy would preserve subtle fingerprints of that transformation. Unlike stars or planets, dark energy does not possess shape or direction in the ordinary sense. It does not spin. It does not form visible structures. It simply exists everywhere, influencing the growth of the universe itself. This makes it especially fascinating in the context of an upside-down cosmos. If anything were capable of revealing changes affecting the fabric of space itself, dark energy might be among the best candidates. Of course, it is equally possible that dark energy would remain entirely unchanged. The universe might slowly alter its orientation, while the mysterious force driving cosmic expansion continued, operating exactly as before. In that case, dark energy would serve as a profound reminder that some aspects of reality are indifferent to the concepts of up and down that humans naturally carry from life on Earth. As centuries turned into millennia, and millennia into millions of years, future generations might develop theories far beyond those of the present age. New mathematics, new technologies, and entirely new ways of thinking could emerge. Questions that seem impossible today might become ordinary subjects in classrooms and observatories. Humanity's descendants, or perhaps other intelligent beings elsewhere in the cosmos, might eventually understand dark energy in ways that would appear almost magical to present-day minds. Yet even without complete understanding, the existence of dark energy reveals something beautiful about science itself. Some of the greatest discoveries begin with mysteries rather than answers. The realization that most of the universe consists of invisible and poorly understood components teaches humility. It reminds observers that the cosmos is not obligated to conform to human expectations. In a universe slowly turning upside down, dark energy might continue its quiet work unchanged, expanding the vast distances between galaxies while civilizations rise and disappear upon countless worlds. Stars would continue shining, galaxies would continue drifting apart, life would continue asking questions. And perhaps that is one of the most comforting images imaginable. Beneath all the mysteries, beneath the unknown forces and invisible structures, the universe would still remain a place of order and continuity. Even as its deepest secrets unfolded across unimaginable spans of time, the great expansion would continue. Gentle and silent, carrying galaxies ever farther into the darkness, while preserving the endless wonder that has always inspired those who look upward and ask what lies beyond. Among all the mysteries surrounding the universe, perhaps none is more familiar, and yet more mysterious than time. People experience it every day. Morning becomes afternoon. Seasons pass. Children grow into adults, and memories slowly accumulate throughout life. Time feels steady and natural, so much so that most people rarely stop to wonder what it truly is. Yet modern physics has shown that time is far stranger than common experience suggests. In a universe slowly turning upside down, understanding time would become one of the most fascinating questions imaginable. At first glance, the answer appears simple. Human beings would probably notice no difference at all. Clocks would continue ticking. Hearts would continue beating. Days would still follow nights. The aging of living things would proceed normally. From the perspective of everyday life, the flow of time would feel as familiar as it always has. This may seem surprising, but it reflects an important principle. People do not experience time in isolation. They experience it together with everything around them. If a change affected the entire universe equally, observers inside that universe might have no direct way to recognize it. Just as passengers aboard a smoothly moving ship often feel perfectly still, inhabitants of a changing cosmos might continue living ordinary lives without sensing anything unusual. Even in the present universe, time is not identical everywhere. According to the theory of relativity, clocks run differently depending on speed and gravity. Astronauts traveling at high velocities experience tiny differences in time compared to people on Earth. Clocks, positioned on satellites, tick slightly faster than clocks on the surface of the planet. These effects are extremely small in daily life, but they are real and measurable. Modern navigation systems depend upon correcting for them. This discovery transformed humanity's understanding of time. For centuries, people assumed that time flowed uniformly throughout the universe like a perfectly synchronized river. Instead, scientists learned that time and space are deeply connected. Together they form a structure known as spacetime, where motion and gravity influence the rate at which time passes. If the universe itself gradually changed orientation, future physicists would naturally investigate whether spacetime was being affected. Massive observatories equipped with incredibly precise atomic clocks could compare the passage of time across different regions of the cosmos. Tiny differences that would escape ordinary perception might become detectable over centuries or millennia. Imagine civilizations spread across many star systems, maintaining clocks of extraordinary accuracy. They could exchange signals and compare measurements across vast distances. If subtle changes in spacetime accompanied the inversion of the universe, these networks might reveal patterns invisible to individual observers. Such discoveries would require patience beyond anything humanity has yet achieved. But the cosmos itself operates on timescales where millions of years can resemble brief moments. Interestingly, human perception of time is shaped not only by physics, but also by psychology. Children often feel that summers last forever. Adults frequently remark that years seem to pass more quickly with age. Emotional experiences alter the subjective sense of duration. Moments of fear may feel prolonged, while joyful events sometimes seem to disappear in an instant. This means that the experience of time is influenced both by the universe and by the minds experiencing it. In a slowly turning cosmos, entire civilizations might adapt to new understandings of time without any sense of crisis. Just as modern people comfortably accept ideas that would have astonished ancient philosophers, future generations could grow up regarding strange properties of spacetime as ordinary facts. School children might learn concepts that currently exist only within advanced theories. The arrow of time presents another fascinating mystery. Human beings remember the past but not the future. Eggs break, but do not spontaneously reassemble. Smoke spreads through a room but never gathers itself neatly back into a candle. These familiar observations create the impression that time possesses a preferred direction. Would an upside-down universe reverse this arrow? Most likely not. The processes that govern entropy and the flow of events would probably continue much as they do now. Memories would still accumulate. Causes would precede effects. Life would continue unfolding from birth toward old age. The orientation of space and the direction of time are not necessarily the same thing. Future philosophers might spend centuries debating these questions. Some would argue that time itself is fundamental. Others might suggest that time emerges from deeper structures hidden within reality. Entire schools of thought could arise around the meaning of temporal experience in a universe undergoing slow transformation. Meanwhile, ordinary life would continue. People would celebrate birthdays. Trees would grow. Rivers would flow. Music would be composed and memories would be cherished.